connection. Okay. Can you hear me, guys?
Yes.
Yes, yes.
Okay. طيب, بسم الله الرحمن الرحيم. We start with our first chapter, which is an introduction to cyber physical systems. It's two parts. Okay, cyber physical systems, the definition of the cyber physical systems, and the security related to, let's say, the aspect or security aspect of the cyber physical systems. When we talk about cyber physical system, has anyone an idea about what is a cyber physical system, guys?
Maybe it's something related to hardware that we need to protect.
Hardware. Any other definition? Any other idea? What can you see here in this term, cyber physical?
That it can't be virtual.
Virtual, not virtual. So we do have here two words. We do have cyber and we do have physical. Physical is understandable. Okay, and cyber, what is cyber?
And it's not what's it called? اللي هو it's in the web يعني it's not physical.
Computing, so let's say something that is related to computing. Okay, so when we talk about a cyber physical system, that is any system that does have two parts. It does have a physical part and it does have a computing part. Okay, and it is called, let's say, a mixed systems. Okay, it's not like you do have only physical system, like a machine, for instance, which doesn't have any computing part. Like, for instance, my glasses are physical part. They don't have any computing part on them, unless you have, let's say, intelligent glasses. At that moment, we say that that glass is a cyber physical system. It is because it does have two parts, physical and cyber. Okay, so here whenever we talk about the cyber physical systems, we are talking about, these are a new generation of systems. Okay, a new type of systems that have a mix, that we call them mixed systems, because they do have, as I mentioned, a computational part and the physical part. Okay, if you go back to, let's say, yes, a decade ago, you do have a manufacturer, for instance. Okay, and that manufacturer has machines that they don't have any capability being controlled over the internet, for instance. They are not computerized. They are just mechanical machine. Okay, those mechanical machines are only physical part. They do have only physical part. However, with, let's say, the advance of the technology, okay, the new machines, okay, the new systems now consist of both parts. They consist both part, which is the physical part and the computing part. Okay, and this system, when we talk about the mixed systems, computational and physical part together, okay, you can find them at different types of model, okay, in your life. You go, for instance, from the smallest cyber physical system. Let's say you go to a sensor, okay, a small sensor. A small sensor is a physical part, but it does have a computational part where it does have the capability of reading data, for instance, and sending data through network, to wireless network, to another device, for instance. It is a cyber physical system, but it is at, let's say, small scale. Okay, guys? Now, the idea about the CPS, or the cyber physical systems, is the whole idea is to monitor the physical processes behaviors. And here we talk about physical behaviors, okay? And we take action to make that physical behaviors work properly, okay? For instance, if we go to okay, let's consider, for instance, I do have, this is a water, okay? This is a barrage, okay, where, let's say we are storing, let's say, the water that comes from the rain, okay? When it rains, okay, you do have the water is stored somewhere, okay, in the barrage, okay, and you do have, for instance, let's say here you do have let's say houses nearby that barrage, okay. What can happen, Shabab?
Maybe it floods over the barrage and then
it floods over the
the
barrage.
houses.
Yes, good. And here I do have we do have a river, for instance. Let's say we do have a river nearby, okay? So what you can do here when you talk about monitoring physical process, okay? The level of, let's say you want to monitor the level of the water at the barrage, okay? This is physical process. This is physical thing. Okay, you agree, Shabab? It is a physical thing. It is water, does have a level, something that does exist. But I don't want, for instance, that level of water reaches some threshold. Okay. Whenever what I should have here, for instance, I will have a continuous. So I do have sensors, for instance. Let's say I do have sensors. Let's consider that I do have sensor here. Okay. Now, whenever, let's say, when the water reaches that level, the sensors will detect that level of the water, okay, and it will send, for instance, it will send the information, and you do have somewhere, okay, somewhere I do have, let's say, this is a control room, okay, when you do have people working there and watching and analyzing, monitoring the level of water, okay, that sensor will send the data continuously, okay. Let's say you do have many sensors at different level, okay. Now, when that sensor sends the data to the control room, people working on that control room, for instance, they will send back a command, okay. We do have here, let's say, I do have a valve, okay. Let's say this is a valve, okay, that will be open and let that water goes, for instance, okay, through that valves, okay, and pouring that water into the river, just to prevent that water from going out and flooding, for instance, the whole, let's say, town or city. That's why when we say a CPS, this is a CPS system. The whole system, when we talk about the system, because we're going to see later, it is a complex system. When we talk about cyber physical systems, it is a system of systems. You do have many components working together in order just to, for instance, to provide some, let's say, to achieve some objectives. For instance, here, our objective is to prevent flooding that town, for instance, by having such system here, okay. We are monitoring the physical process, okay, by using, for instance, sensors, okay, and we take action, we take proper action to make that physical environment work properly and better, because that water is used, for instance, for we are using water to generate, for instance, electricity. We are providing, for instance, something better for the life of these people by providing them with electricity, one of the benefit of that barrage, but that barrage can turn, let's say, into, let's say, disaster if that level of water is not controlled. So here, when we talk about specifying, when we talk about CPS or the aim of the CPS, as we mentioned, we are trying, we say the idea about the CPS is, for instance, to, as we mentioned, we are controlling that physical process, okay, the behavior of that physical process, and we take action just to make that physical environment work properly and better, continuously providing electricity to that town and so on. Okay, so this is just a small idea about, let's say, a CPS or a cyber physical system, what a cyber physical system can do. And as we mentioned, that CPS, okay, has a tight integration among, we do have an integration between many parts. You do have computation part, you do have a networking part, and you do have a physical object. This is thing that integrate one piece, one cyber physical systems has all those integrated parts working together to provide, let's say, or to make that physical environment work properly and better, for instance. Okay, I do have computation part, for instance, I am calculating, I am collecting data. Networking part, I will, once I collect data from that sensor will send the data to the control room, to people who are monitoring that barrage, for instance. And we are using networking part because we are sending, okay, through wireless, for instance. And we do have physical object, which is the device itself, the sensor itself, the valve itself, for instance. And you can, let's say, find plenty of examples that can be considered as cyber physical systems. I might have a sensor within my room that will control and read, let's say, the temperature of my room. If that temperature reaches some threshold, automatically there is, let's say, a link between the devices that will switch on automatically my AC, for instance, and vice versa. Okay, so these are, let's say, we talk about, let's say, the tight integration, because all those parts work together to provide some specific task, to achieve some specific task: computation, networking, and the physical one. That's why we said cyber physical system is two parts. You do have a cyber part and you do have a physical part. When you talk about cyber part, included the networking part, because it does have the capability to send data to the control room, to receive back the data in order to trigger, for instance, some types of action, mechanical action on that valve to open or to close, for instance. Clear, Shabab? Yes, guys?
Clear.
Yes, clear.
Yes, sir.
Hello?
Yes, doctor, clear.
Yes, doctor.
Clear.
Clear.
Because sometimes I told you, because sometimes I lost connection. I will find myself talking to myself. Okay, Shabab? I don't trust the wireless connection here. Sometimes from time to time, I want to make sure that you are listening and you are listening to me. Okay? So this is for, let's say, the first bit of the cyber physical. And we do have the embedded devices, okay, are also networked, because sometimes you do have within the same device, you have, or let's say I have a machine, that's like a computer. You have a motherboard, and you do have, for instance, CPU, you have RAM, you have buses, for instance, okay, and all those were embedded within the same system. They are built in, that are inside one device, one CPS device, okay, and also they are, let's say, used, for instance, in CPS, used to sense, manage, and monitor all the physical part of, let's say, that systems. Okay, you can have separate systems working together, as you can have one big system that has embedded component inside it that do the same job. Within one machine, you do have sensors, you do have management process and monitoring process, and you can receive command, you can receive order, and so on. as we mentioned, it is not like a traditional computer, like a normal computer or network systems. It is, as I mentioned, it is a systems of systems. Now, when we talk about system of systems, now from the perspective of the security, that means if I do have, it's not like, for instance, I do have one component, I will look only to the security of that component. Now, if my component is made up of many components, that means the security risk will increase because each part or subcomponent has its own security risk. It has its own vulnerability. That means if, for instance, as if you go back to our example, okay, if you go back to our example, for instance, okay, if this sensor is vulnerable, it is hacked, for instance, okay, that means I will no longer receive, or someone will tamper with the data sent by that sensor, okay, instead of sending the real data, okay, that hacker will send me fake data, okay, which I consider that the level of water has not reached yet its limit, but in reality it has reached, and it will create a disaster, to create a flooding. Okay, so that means when we talk about, let's say, vulnerability and the risks associated with cyber physical systems, okay, it does have a distributed impact. Distributed impact because the risk of vulnerability of these sensors will have, it's like you are propagating the risk. Okay, it will have has an effect on the control room. It will have an effect on, let's say, on that valve. It will have an effect on people's life and so on. It is because they work all together, they form my cyber physical systems, and any breach or any vulnerability, any risk towards one part of my cyber physical system or my part, it will induce, let's say, the distribution and propagation of such vulnerability and risk. Okay, and as I mentioned, it can cause a catastrophic failure. Specifically, here we are talking about this is a very important part in cyber physical systems, which is a critical infrastructure. Does anyone have an idea? A critical infrastructure?
Components
Yes,
that
guys?
are absolutely necessary, doctor.
Yes, like here, for instance, that we gave an example that we are providing electricity to the town, for instance, or to the city. Okay, a power grid. We are providing such service. It is a critical infrastructure. It is a very important infrastructure because any downtime for that, for instance, infrastructure will induce a failure and damage. Can you imagine, for instance, you do have here hospitals, people are relying on electricity, on machines that are linked to, let's say, to the electricity for their life, for instance, within the hospitals. And if that infrastructure or power infrastructure or power grid or smart grid is hacked and it is down, that means it will have a big impact on the life of people. And you can extend it to the businesses and so on. So that means this type of infrastructure is called as a critical infrastructure, and it is very important to secure those cyber physical systems that are part of a critical infrastructure. Okay, Shabab? Now, as we mentioned, because we are talking about cyber part and physical part, okay, that means the combination of threats, the combination of risks, both of the physical and the computing part or the cyber part, okay, will have a big impact. Because we're not talking about the threats of only one side, we are talking about two sides. Threats towards the physical one, and threats towards the cyber part 1. Okay, I might have a threat toward the physical part. I might have this valve is damaged. Okay, and when it comes time to open the valve will not work, for instance. Okay, for let's say a failure of the device itself, the failure of the valve itself. Okay, I might have a problem with the sensor itself. I might have with the communication. When I send the command to the valve to be opened, maybe the communication is not done because of failure of communication. We do have a problem of communication. So one has, it might be a natural problem, or it might be, for instance, based on a hacker who has let's say intervened with the communication, or let's say prevented the communication between the control room and that valve. Okay, that means it is very important when we talk about what is the risk, what are the different threats. Okay, we cannot apply, let's say, the threat or risk assessment model or framework that is applied for a normal simple computer, and we apply it to the cyber physical systems. It is not the same thing. Okay, when you talk about let's say analyzing the threats and let's say discussing the risk assessment for a cyber physical system is different from talking about cyber, let's say, risk assessment of a normal computer or an IT system. Because of that part we do have, because of that physical and cyber part. As I have already mentioned, that those cyber physical systems are part of our life. They are improving the living condition, okay, of people. Okay, like here we are, by providing electricity, for instance, we are contributing, those cyber physical systems are contributing to the let's say daily life of those people. They are contributing to the national economy. Okay, when you do have electricity that will be generated, it will let's say the machines will work, the business will run, and everything is linked together, and it is participating in improving the national economy of people, for instance, improving the health, welfare of individuals, specifically those people living in rural places. Okay, when you do have people living in the town, in the mountain, okay, those physical systems are contributing to, let's say, to the welfare of those people living in such a harsh environment. Okay, so it is very important to keep those devices, okay, running, and let's say without, let's say, zero downtime, in order just to keep let's say that level of living for those people. As example for the critical system, I mentioned power grid. You do have a next generation system of automobiles, for instance. Okay, you do have intelligent cars, you do have intelligent highways, or you do have the panel that will display automatically, let's say, the flow of, let's say, of the traffic, and sense alert and all the stuff that are considered as intelligent highways. Okay, you have intelligent vehicles, you do have airspace management. There are plenty of let's say example that can be categorized are a cyber physical system. So in terms of defining a CPS, you will find many definitions that are different, let's say, resources, different books. You do find many types of definition for the CPS, but just to come to, let's say, to a proper definition, we can define it as a new generation of systems, okay, which is new types of systems that mixes computational part and physical capability. Okay, to be able to, it is very important to interact with humans through different models. When I talk about different models, you can, as we mentioned, these are models. Okay, power grid is one of the model. New generation automobiles are a new model. Intelligent highway is another model. But all those are considered as cyber physical systems. Okay, Now, the advantages of using a CPS, okay, because it is based on their quick response. Okay, when we said when you receive live data, okay, of the level of, let's say, the barrage or the water, for instance, you have to act quickly. Okay, there is no delay. You shouldn't have any delay in responding to such data. So you will automatically send your command quickly to and respond to such event, for instance. Okay, precision and adaptability work in risky conditions. Precision, that means you can control, for instance, the level of the water at, say, a high precision, for instance. Okay, and it does work in a risky environment. You can work in risky condition in the mountains, and the different types of, let's say, weather environment. Okay, distributed coordination. It is the coordination between the different devices works in a distributed manner. Not necessarily they are all part of one device. There might be different devices working together in distributed manner. High efficiency, okay, in their work, and enhancement for the societal, for instance, well-being. They are improving the life of people. They are contributing to improve the life of people, as we mentioned previously. Okay, cyber physical system or CPS, it is also an umbrella for any system that include, for instance, robotic, machine automation, for instance, industrial control system within a manufacturer. For instance, you do have a car manufacturer. It is an industrial system where you do have many machines, maybe a robot that works in distributed manner in order to provide to build some cars, for instance. You can have what is known as a SCADA systems. We're going to have a dedicated chapter about SCADA systems. Industrial internet of things, all those can be considered as a CPS. Okay, as we mentioned, from the small scale to a large and bigger scale, but they all share the same key attribute. Okay, when I talk, they do have computing part, they do have physical part, and so on. And the risk toward those physical systems are shared between, let's say, the different types of devices. Now, when it comes to dividing the categories of the CPS domain, okay, even for those, we said it is an umbrella that holds many systems, but those systems can be divided into two categories. We can divide CPS system into infrastructural category, and we can divide them or categorize them under personal category. Okay, now the functions of the CPS are between the two categories. Okay, for instance, they might provide the same functionality, but sometimes when we talk about the security risk between those two categories are different. When you talk about, for instance, a watch or smartwatch, security is different from talking about a big machine or power grid security. Okay, even they both are categorized, they are considered as cyber physical systems, but they do have their own, let's say, risk vectors. Now, for the first category, which is the infrastructural CPS, here we talk about these types of CPS are found in industry and are very critical to our modern life. When we talk about smart grid or power grid system, okay, it is providing, for instance, power to people, for instance, and that power is needed in a modern life. We cannot live without let's say, without electricity, not like let's say a decade ago. So it is modern life that necessitates to have, let's say, continuous, let's say, electricity, for instance, continuous power. Okay, so here when we talk about in the infrastructural CPS, we said that the physical size or side is emphasized. What is meant by the physical side is emphasized? That means we do have, for instance, okay, you do have at the beginning, let's consider this is a big machine. Okay, and this is, let's say, a manufacturer where you do have a big machine. I say this is a machine 1. Okay, now when you, let's say, let's consider this is an old manufacturer. Okay, an old manufacturer before let's say the development of the creation of the computers and the technology related also to the computers and to the internet and communication. We do have a machine that runs, okay, that produce items, okay, and this can be considered as an infrastructural CPS. Why? Because mainly this machine is based on the physical aspect. It does have little part of computing or not at all any type of computing capability. Okay, let's consider that I do have this part from that machine, only this part is related to the computing part, okay, within that machine. That means this is computing part. Can you see my screen, Shabab?
Yes, we can.
Okay,
Yeah.
so if you can see here, if you can just, it's like an analogy. The emphasis of this CPS is the physical part. If you are looking at how many parts, or let's say the percentage of the physicals compared to physical part compared to the cyber part, the cyber part is a small portion from that machine. We consider that this machine as an infrastructural component. Okay, why? Because the physical size is emphasized. Okay, and that cyber part, as we mentioned, it has been added later. At the beginning, as I mentioned, let's say this manufacturer date of, let's say 70 years ago old. Okay, it does have only mechanical things. It doesn't have any computing capability. And by the time, okay, let's say the owner of that manufacturers or the descendant of the owner said, we need to modernize our manufacture. We need to modernize that machine. Let's say if we can, we have to add a part to that machine in order just to computerize, at least to computerize one thing, maybe one process from that machine. Okay, this type of machine is considered as an infrastructural one because the cyber side is added for convenience. Okay, in order just to access and control that physical machine. Okay, but the main thing is that infrastructural is the physical part. Okay, and the connection now between the machinery and external computer network may be undocumented or poorly understood. Why? Because mainly when that machine, it is an old machine, okay, if it did have a computing part at the beginning, okay, it was a poorly documented, let's say, that part, that computing part was not well documented, okay, because it was done 30, 50 years ago, for instance, or let's say 15 years ago, 20 years ago. Okay, there were no, let's say, idea about documenting how that computing part will work. At that moment, no security at all was taken into consideration because there was no breach towards security. There was no hacking at all. Okay, and these types of cyber part has been added just for, let's say, to control, to add some extra modernization to that machine, for instance. Okay, and here we talk about the connectivity has often evolved over a long period of time because through the long time, let's say 30, 15 years ago, 20 years ago, over the time, let's say there were a lot of connections added to that manufacturer, so new, let's say, processes that have been added, and you lost even, let's say, the understanding of how that device works and what are the different types of connections related to that machines. Okay, and now when we talk about The concern related to the physical or infrastructural CPS, okay, is we need to keep those infrastructural CPS live. Okay, we don't allow maybe any downtime of those machines. That's why the main concern is the availability. As we mentioned when we talk about our, let's say, example where we want to provide electricity to the town, for instance, okay, our main concern of this CPS system is how to make that CPS system available 24 hours, 7 days a week, okay, because our main concern is not to have any shutdown. Anytime we don't allow any downtime where we don't provide electricity to the town, for instance. So the availability is the main concern, and it will override all the concerns, okay, against confidentiality, against integrity. The main thing is the availability is the main point that should be provided in such infrastructural CPS, because the modern society, because many people are depending of such CPS system. Okay, we care about how we can continuously keep receiving electricity. We don't care the other things, okay, we will leave it later, but the main concern is the availability, how we can achieve the availability within that CPS system. Okay, Shabab?
Okay, doctor.